We have actually pictures of the rollout of the launcher. And in a moment, hopefully, we'll be able to see that, because this huge rocket, it wasn't always in Baikonur. It had to be brought there. There we see the lander still. Tell us, bit by bit, what's been happening there on Friday.
So here we see the spacecraft with the TGO with the EDM mounted on top already, and it's being brought into the horizontal position. Because that's the way Russian launches work. Everything's integrated horizontally. In Western rockets, it's vertically, and it's much more complicated, but of course it's kinder on the payload. And here you have to be careful. You have to change it from 90 degrees to 0 degrees, and then move it in. Here you see one half of the fairing coming in. It's integrated already, the lower half of the fairing. That will protect the payload during the ascent from the thermal and load and the drag forces of the atmosphere. Here it's being closed, and here it's on a train. So yeah, it's transported from the integration facility to the launch pad by train, of course very slowly, very carefully. And you can see that there's kind of hood on the fairing with pipes going in and out, and that's air conditioning, so you have a controlled environment underneath the fairing all the time.
Okay, they're all really, really very careful to lift it now. I think they're raising it now.
Yes, now it has to, well, now finally it has to be brought to the upright position so it can be launched. And it will stand there. It's just freestanding. It's not clamped down or anything. So this was on Friday, and today it was, the lower 3 stages were filled with 620 tons of propellant. The upper stage, the 4th stage, the breeze, had already been filled before it was integrated.
Okay, and I think, Michael, now that we know what's been done before the launch, it's ready for us to concentrate on the launch, which is happening in about a minute from now. That's a good moment for us to just stay quiet and let you watch as things unfold. We'll pick up with you later again.
окончания точного приведения весь запуск двигателей первой ступени.
I think it is safe to say that ExoMars has lifted off into space successfully. That means the very first European-Russian Mars mission is on its way. Well done. So Michael Kahn, again, expert in mission analysis, and you've calculated the flight of ExoMars. You're still with me, of course. Sadly, it was a bit overcast, so we couldn't see all the stages, but you can tell us what is happening next. I mean, as we speak now, the first stage, I believe, is almost burnt out.
Yeah, the first stage burns out in 2 minutes. So it goes through more than 400 tons of propellant in just 2 minutes. Mm-hmm. And by then it will have reached more than 40 kilometers of altitude and be traveling at 6,000 kilometers per hour. That's always the thing with rockets. First you go up and then you go fast. So you have to get out of the atmosphere, and then, so it's separated now. We can see that in the animation. And what they do is a hot start of the second stage. So it starts while it's still attached, so in a split second. Mm-hmm. The second stage is burning. It will burn for 3.5 minutes. And that will take us to more than 100 kilometers of altitude, almost 120, and 16,000 kilometers per hour. But first we'll see the fairing come off. We should have been going through max Q approximately at the time of separation. That's the highest heat load, so it can reach a couple of tens of kilowatts per square meter, and you do want something protective over the payload when that kind of heat load comes in.
Yeah, so what we've just seen, ideally this is how it works. Obviously that wasn't a real image, it was an animation for us to get an idea.
Yes.
Yeah.
So the next step should be the separation of the fairing.
Yeah. Now all these empty stages, the first, the second, the third stage, I mean, they're all burning off and then they're being dropped where? What's happening to them?
They have designated drop zones where these stages fall. And
so where shouldn't I go next?
Well, you're not allowed to go there. Okay. But the first stage, so because you're first going up, the first stage drops very close to the launch site. And even everything up to the second stage drops within less than 2,000 kilometers of the launch site. It's only the third stage that travels really far. That travels, it's dropped, it almost reaches orbit. It's just suborbital, and it will fall into the Pacific Ocean.
Now, there are these 3 stages, and then there's another one called Breeze. The others don't have a name. What is the significant difference here?
Well, they do have a name, I suppose. I can't remember it. But,
okay.
Those 3 stages are in itself a self-contained rocket. So if you want to go to low Earth orbit, you just use the 3 lower stages. But if you want to go to anything beyond low Earth orbit, you have to use the Breeze on top. And then you still have a differently commanded, pre-programmed ascent profile for the 3 lower stages. But then the Breeze stage is much cleverer than the previous ones. It can start its engine, switch it off again, turn, wait, switch it back on again. And it can survive up there for 24 hours. So it's really a self-contained spacecraft. So we can consider the Breeze with ExoMars on top as a spacecraft until the separation occurs.
So it's intelligent. What are we seeing here right now, by the way?
We're seeing the ascent trajectory the way it should be. As it curves away, you see it goes up first and then curves to the northeast. Actually, we have to go to the northeast. We don't go directly east. We have to go to the northeast, so to skirt. So you see the ground track. If you plot it on a map, it would be skirting Mongolia. So it would stay just inside Russian territory. All of this has historic reasons.
Okay.
And then we will see it going out over, reaching orbit above the far east part of Russia. That's when final orbit of 175 kilometers, the parking orbit will be reached. And then we're going to have about a bit more than an hour of waiting until Breeze boosts the whole stack into a higher orbit, eccentric orbit, which goes up to 5,000 kilometers. Then we have to wait for about 2 minutes. Sorry, we have to wait about 2 minutes, and then it will go into another higher orbit again. And then we have to wait. Then comes the excruciating part. We have to wait for 6 hours. And sorry, did I say 2 minutes? 2 hours, and then 6 hours wait. And then will be the final burn. That will be the 4th Breeze maneuver. It will be about 8 o'clock our time by then.
Exactly, it's a long day. Yeah.
Yes.
And I just hear that the second stage is gone now, and the fairing jettison is basically happening as we speak right now. What exactly happens? Because we can't obviously see it.
Well, when the fairing is jettisoned, it falls apart in two petals, and these fall to the basically they fall back to the Earth. They don't have orbital velocity. So after that, we'll be looking at the third stage, and the third stage burns for 4 minutes, and then and then there will be a short coast arc when the engine, the breeze hasn't switched on yet, and then we'll see that burning for above a bit more than 5 minutes.
Yeah. By the way, I've mentioned earlier, I'm sure you heard it, that the launcher, the Proton M, is one of the largest, heaviest rockets in the world. Why was it chosen, the Proton M?
We have the heaviest spacecraft ever sent to Mars, and this spacecraft has to be accelerated to a high velocity. We leave the Earth with 3.7 kilometers per second, so that's really high. That's a lot. So in order to achieve that, we need a big rocket. So the smaller rockets of Soyuz or that kind of class that launched, for instance, Mars Express, would not have been able to make it.
So you need a real powerhouse to push it all up. And I mean, of course, this breeze is in this sort of elliptic orbit, and it gets even more elliptic, and it passes a radiation belt, which I find a bit scary.
Well, that's inevitable. First it's in a circular orbit, it's below the radiation belt, and then after the first maneuver it will push up the highest part of that orbit to 5,000 kilometers, so definitely it will be going through the Van Allen belts, the radiation belts, and twice, once on the way up and once on the way down, and then on the second orbit again. There's nothing you can do about that. You can just make your spacecraft resist that, but actually it's not anything that's so unusual. It happens also to geostationary satellites.